Welcome to this session. Over the last couple of sessions, we have been discussing about the gang of 4 patterns and the GOF patterns. And we had said that we will initially discuss very simple, intuitive patterns which are applicable in a wide ranging problems, very popular patterns. We started looking at the Feshad pattern, very simple pattern, and then we had started discussing about the observer pattern. Now, let us continue our discussion about the observer pattern. The observer pattern addresses the problem when we have a model or a subject. The observers, they want to get updated or they want to observe when changes can happen on the model, but the change to the model happens asynchronously. They may occur any time, and therefore, continuous polling from the observers about if there is a change is highly inefficient. It is not a proper solution that the clients keep on polling keep on invoking the method on the subject class is not appropriate. If the number of observers is fixed, like let us say there are only 2 terminals on a computer and the changes need to be shown on the computer, then possibly the model object can show the changes directly, because these are directly coupled to this, and they just need to invoke the method on those. But we are looking at a situation where the number of observers is not fixed. New observers may arise, some observers may drop out, and the changes in the model cannot be predicted. We are just taking the example of a cricket game, and there are many observers of the cricket game. Some are sitting on their desktop, some are using laptop with various operating systems and so on, and some are using mobile phones, etc. And these clients or the observers, they can join any time and drop out any time. And we are looking at a good solution about how this can be solved, how the interaction between the model element and these observers are the view elements. How the interactions can be structured. We have so far in all the discussions that we had, we said that in any application we will find the model objects or the entity objects. These store information, and there may be some controller objects, and then there are the interface through which service requests may come, and we can have observers. Or the view objects. I think we will just write view, model view controller. So, we will write view, the view objects, and is it that the view objects directly invoke services on the model object? In that case, the view object will be coupled to the model object. And also the model object cannot really update the view, because does not know the view objects. They may come anytime and also they may leave anytime, and that is the problem we are addressing. And the model objects, they change due to various reasons. Maybe the cricket game, some event occurred, run scored and the model got updated, or maybe in a networking some message come and the network model got changed, or maybe in a stock market the model is the prices of the various stocks in the market and some trading took place and the price of various stocks changed asynchronously. You do not know when it will change, but then the value changes asynchronously, and then those who are watching the market behavior, the market, they would like to see some specific stocks, what is the price, and whenever there is a change only they need to be notified. So, that is basically the problem that is addressed here. Now, let us look at the solution here. The solution offered by the observer pattern is that define a one to many dependency, so that when the model changes state, all the dependents are notified and updated automatically. Let me elaborate the solution. There is a one to many dependency. So, we have to set up this one to many dependency. Somehow we need to have this dependency one to many, these are the observers. And this is the model, and there is a one to many dependency. So, that whenever there is a model changes, the observers will get notified, observer 1, observer 2, observer 3 and so on. But then the problem here is that the observers can come anytime and go anytime, and for that, as we will see the details of the solution offered by the observer pattern, the observers need to first report to the model that they are interested, and then the model stores the ID of the observers, and when they leave they just communicate to the model about leaving the observation. Many observers can attach themselves to the model stores their ID, and whenever there is a change it communicates to the observer. So, the solution is simple. There is a one to many dependency, not many to one. Many to one would have been if the different observers here, they would be keep on requesting the model or the subject. There can be many observers and the observers vary dynamically, some may come and go, and the model changes state asynchronously, and also the different observers may react differently to a change. For example, somebody may be using a desktop and there may be the actual match is being shown, the video is being shown, and in some cases maybe just the score is being shown, and in some cases maybe only the message is being played, that a run is scored. So, different observers depending on the notification may act differently. Some are just saying that match is scored, some is just updating a table, and some playing a small video about how the run was scored. and the solution here offered is that the subject and the model should be decoupled from each other. That gives us flexibility to add more observers and also remove the observers. And we can also have additional observer types. We can view the model changes. So, there are, in summary, there are 2-3 things that we must find for the observer pattern to be applicable. The first thing is that the model must change asynchronously. If the change is synchronous, that means predictable change, then the clients can directly call on the model element. For example, if it is a daily update on the price, every next day only the price will get changed, then the clients can invoke at every day beginning. In that case, the observer pattern is not applicable. The observer pattern is applicable when the model changes asynchronously, unpredictably. For some time there will be no change, and sometimes some aspect may change, and so on. And the second thing for the observer pattern to be applicable is that the number of clients should vary dynamically. The type and number of clients vary dynamically. That is, with time more observers may be interested, some may drop out, that flexibility should be provided, and under these situations we use the observer pattern. If the number of observers is fixed all the time, only those few observers or many observers they are fixed, then also this pattern is not applicable. Here is a non-software example of the observer pattern. A bidding is going on and different clients are bidding different amount based on what they are observing. And they cannot see each other, and the model here is the state of the bid. The person bidding observes the maximum price is 33 and then updates it to 33, and as soon as the 33 is updated here, then everybody is able to see 33. This is an example of a observer pattern, non-software example, because here the model has a state which is the latest price that has been accepted, and the price can change any time to some amount. It can be 17 or 21 or 33 or something, but then as soon as the price is updated, then everybody can see the price. So, this is somewhat like a observer pattern that we are going to discuss. The accepted price can change any time, and whenever it changes, then the persons who are bidding are notified of the change of the price. This is another example of the stock quote service. The market data is obtained, real time market data feed comes here to this class, and then so this is the one stock market data is coming here. The market data, the state of the market is changing, and then there are many observers. And more observers may come in and some of the existing observers may drop out, and they may be interested in specific stocks. For example, customer A may be interested about A, this customer is requested about D customer, this is about C, this is also C and so on. Now, the problem here is that we not only need to have the customer notified of the change, but also the specific stock that changes. Now, let us see what is the solution offered by the observer pattern. Here the main idea is that the different observers will first request the model that they are interested in some behavior. The model or the observable will register them, and as soon as there is a change, then all the dependent objects who have registered are notified. And since here the dependency is set up and broken as the request from the observer comes to get attached to the model, and the model registers them, and whenever they want to go away, they just send a request and the observer decouples them. This prevents tight coupling between the classes. The solution offered here is that the observers request the observable to register them, the observable stores the reference to the observer during the registration, and when there is a change to the model notifies all the registered observers. But then it just notifies that there is a change, and different observers might be interested in different aspects of the change. For example, some observers may be interested in the stock price of A, other observers may be requested in stock price of B, C, etc. Now, once the observer is notified of a change by the model, then they can query from the observer the specific price of the stock they are interested. Now, this is the class structure recommended by the observer pattern. As you can see that there are 4 classes here. One is the subject interface. This is the interface class, and we know that interface is a good mechanism to decouple and reduce coupling, to reduce dependency. The subject interface provides prototype methods for the observers to attach and detach, and also it has method to notify, and the concrete subject implements the subject, and it can get state, that is it can notify the clients when a state change occurs. And there may be other classes which are trying to set state of the concrete subject that we have not seen, just like the stock market. The market may call the concrete object set state for when a specific change occurs, and now there are observers which have attached to the subject, and then as soon as change occurs, then the concrete subject notifies the corresponding observers. And then the observers, they can update themselves based on the notification. So, that is what there are 4 classes: the subject interface, the observer interface. These help to decouple the concrete subject and the concrete observer from each other. We had seen so far how this principle works, programmed to an interface. The concrete subject implements the subject interface and sends notification to the observers. the concrete observer implements the observer interface and provides a definition to the update method and how it can be updated. For example, whether a table is shown about the runs, whether a video clip is played, whether a audio clip is played, and so on. These are taken care by the specific implementation of the update method of the concrete observer. Now, to understand the working little better, the subject, the concrete subject stores the references of the various concrete observers after the observer attaches, they are stored, and as a change occurs, it calls the update method on the concrete observer. Whenever there is a change, the concrete subject calls the update method of all the registered observers. That is what I have shown here. The notify method of the observer contains for all observers that have registered invoke the observer.update, and based on this the concrete observers are notified, but then they may be interested in the update, they may be interested on specific aspects of the change, and they may query the concrete subject subject.getState, and then it returns the state here and the concrete observer state refreshes itself. For example, the concrete observer may be interested in some specific stock price, and once it is notified that there is a change, it just gets the corresponding stock prices. As we could see that there is a one to many dependency setup through the registration process, attach, and then when the subject changes, it notifies all the dependent or attached observers. But a problem with the observer pattern, if we think of it, that even though the observer is not interested in the stock price of company A, but then he has got a notification that the price has changed, and when invokes the get state finds that A has changed, whereas the observer is interested in C. So, there is a unnecessary notification, excessive notification. This may be a shortcoming, but then we can overcome it in various ways. For example, we can just modify the observer pattern little bit and have the observer also determine for which event a specific client or observer is interested, and then only for that event notify that client, but that makes the observer the model more complicated. Now, the concrete subject, as the changes occur, notifies the concrete observer. After the change is informed, the concrete observer queries the subject to find what is the state that has changed, and it changes the state, makes display the correct state, and they are synchronized. If we represent the same thing in the form of a sequence diagram, initially the observers of some file here, the file has many observer. One is let us say information view, that it provides icons, and another is a list view, the list view only lists the file, and the information view it provides detail of the files, size and so on. Here it just lists. Now, let us say the different observers, they first attach the file, keeps track of these different views of the observer, and then as a change occurs to the file, it calls the notify method on itself, and then the different observers are the update method is called on the different observers, and then the observers may request the get state, it returns the state and then they change their own state, and the observer and the model get synchronized. Once the update of the observers is called, the observer may carry out different activities. For example, it may repaint its interface, or it may check whether some threshold is exceeded, and the subject if it had to do if the model had to do this, that on a event what things should take place on the subject, on the observer, that would make the model extremely complicated. So, it just informs that something has changed by calling the update method of the corresponding observers, and the observers take care of what things to be done specific to them. This is the main idea of the observer pattern, and we are almost at the end of this session. We will stop here, and we will have a couple of more examples and also the Java code to illustrate the observer pattern. It is an important pattern, so important that in the Java language itself, the observer and the observable interfaces are inbuilt, and we will see the code, specific code, how to set up a observer pattern for specific examples. So, that given another problem, we will be able to apply the observer pattern. We will stop here and continue in the next session. Thank you.